Hello, we'll be starting hydrogen chloride compounds today. Hydrogen chloride, we know the formula is HCl and molecular weight is 35.5 and the bond is covalent bond. Now these are the points in general to be covered. In this particular video, we'll be covering the preparation of hydrogen chloride gas and its physical properties. So this is the bonding of hydrogen chloride. You know this one, that dot diagram or Lewis structure. This is the covalent bonding. Hydrogen has 1 electron and chlorine has 7 electrons. When they both share, hydrogen occupies the structure of helium, that is duplet structure, and chlorine gets the structure of argon, that is octet structure, and both of them share the 2 electrons, one donated by hydrogen, another donated by chlorine. So this is the orbital diagram of hydrogen chloride, and this is the electron dot structure, or it is also called the Lewis structure. Now what is the occurrence of hydrogen chloride? Glauber prepared this acid in 1648 by heating common salt, which is sodium chloride, with concentrated sulfuric acid. Lavoisier named it muriatic acid. Davy named it as hydrochloric acid in 1910. Hydrogen chloride gas occurs in free state in volcanic emissions. Hydrochloric acid in gas, it is called hydrogen chloride gas, and for acid it is called hydrochloric acid, the formula being same. Hydrochloric acid is present in gastric juice of mammals in very less quantity, 0.2 to 0.4%, which helps in the digestion. General preparation of hydrogen chloride gas, first is by synthesis or direct combination. Moist hydrogen gas combines with chlorine gas in presence of diffuse sunlight. The reaction is explosive in case of if you do this in direct sunlight, but there is negligible reaction in dark condition. But if there is a presence of a catalyst like activated carbon, the reaction takes place even in the dark. Activated carbon here absorbs the hydrogen, which increases the reactivity. Burning jet of hydrogen also burns in chlorine to form hydrogen chloride. Second is by heating metallic chloride with concentrated sulfuric acid. If sodium chloride is reacting with concentrated sulfuric acid at less than 0 degrees Celsius, we get sodium bisulfate and hydrogen chloride gas. Similarly, if the same reaction is taking place above 200 degrees Celsius, we get sodium sulfate and hydrogen chloride gas. With copper chloride and concentrated sulfuric acid, if it is heated, copper sulfate and hydrogen chloride gas is produced. Then go back to the laboratory preparation of hydrogen chloride gas. Now in the laboratory, hydrogen chloride gas can be prepared by the action of concentrated sulfuric acid on sodium chloride. So what are the reactants? Reactants are sodium chloride and concentrated sulfuric acid. The setup you can see over here. The setup of the apparatus is shown over here. This is the round bottom flask. This is the thistle funnel through which the concentrated sulfuric acid is given. Sodium chloride is here in the round bottom flask. Through this delivery tube, it is going into again a concentrated sulfuric acid, which is working as a drying agent, so that we can collect the hydrogen chloride in dry form. So place some common salt over here in this flask and pour concentrated sulfuric acid through this thistle funnel. The reaction proceeds slowly in the cold. If the heat is given gently, there is effervescence and hydrogen chloride gas is evolved in a controlled manner. The gas is then dried by passing through a washer bottle. This is also the washer bottle in there are some different diagram in some other books also. So you can take the washer bottle containing concentrated sulfuric acid, and then it is collected by upward displacement of air in a gas jar. So this is the gas jar, the hydrochloric acid gas is coming this way, so air is going this way, upward direction. So it is collected by upward displacement of air. Now the reactions are shown over here. Below 200 degrees Celsius we get sodium bisulfate and HCl. If heated above 200 degrees Celsius, sodium sulfate is formed. The reactions are shown over here. Now this particular reaction, sodium bisulfate plus sodium chloride, gives you Na2SO4 and HCl gas above 200 degrees Celsius. It shows its acidic nature. Though sulfuric acid is weaker acid than HCl, in these reactions, in all these reactions, HCl is displaced as it is more volatile. Now in case of this reaction, you can take flat bottom flask as well as round bottom flask also, but round bottom flask are normally used to heat at high temperatures. Now why NaCl is preferred for the preparation of HCl over other metallic chlorides? The only reason is it is very cheap. Why concentrated nitric acid is not used for the preparation of HCl? Because concentrated nitric acid is very volatile and it may volatilize along with HCl. So you will get a mixture of HCl and HNO3. So how to do the purification and collection of the HCl gas? This gas is dried by passing through concentrated sulfuric acid, because both are acidic in nature, so they won't react. There are other drying agents, very popular drying agents like phosphorus pentoxide and quicklime, that is calcium oxide. These cannot be used because HCl, that is hydrogen chloride, reacts with them. Like with phosphorus pentoxide, it gives phosphorus oxychloride and phosphorus acid. With calcium oxide, it gives calcium chloride and water. So collection we had already discussed. It is collected by downward delivery as it is 1.2 times heavier than air, and also it is not collected over water because it is highly soluble in water. How to do the identification? If you have a gas jar filled with hydrogen chloride gas, how do you know that? If it is fully filled with hydrogen chloride gas, fume will appear above the jar's mouth. When HCl gas is exposed to air, it gives white fumes because there is a formation of hydrochloric acid on dissolving in atmospheric water vapor. Now if you want to find out whether any gas is filled with hydrogen chloride gas, you have to take a rod dipped with NH4OH, that is ammonium hydroxide, near his mouth. Dense white fumes of ammonium chloride will be produced. It is a very good, very easy reaction, and we had already done it in the previous classes. What precautions you have to take? We'll go back to the diagram. We can see here that the thistle funnel is dipped in concentrated sulfuric acid. So the thistle funnel should be dipped in concentrated sulfuric acid. If it is not dipped, whatever hydrogen chloride gas is produced, it will try to come through the thistle funnel, come out through the thistle funnel. So it will give a back pressure through the concentrated sulfuric acid, so all the acid will be spilled out. Second, the delivery tube should be dipped in the drying agent. If the delivery tube is not dipped in the drying agent, obviously it won't be dried. Temperature should be maintained nearly 200 degrees Celsius, because at higher temperature, that is above 200 degrees Celsius, you can see here there is a formation of sodium sulfate. So at above 200 degrees Celsius, you have more fuel wasted, because which you can get that at lower temperature. If you heat more than 200 degrees Celsius, you will get the same product. So why not to use the less temperature? So if you go for the higher temperature, more fuel will be wasted. The apparatus is made of glass, so this may crack. And third and most important, sodium sulfate will be formed. It forms a hard crust which sticks to the glass and it is difficult to remove. So come to the physical properties of hydrogen fluoride gas. Color is colorless, pungent choking smell, sour or acidic taste, corrosive in nature. It irritates nose, throat and lungs. This is density is more than air. It is about 1.25 times heavier than air. Vapor density of hydrogen chloride is 18.25 and that of air is 14.4. Boiling point is minus 83 degrees Celsius and melting point is minus 113 degrees Celsius. If it is subjected to a very high pressure of about 40 atmosphere and temperature is lowered to 10 degrees Celsius, it is liquefied to a colorless liquid. Hydrogen fluoride gas is highly soluble in water. So that's why it is not collected over water. 1 volume of water dissolves 452 volumes of the gas at room temperature. Means if you take 1 liter of water, it will dissolve 452 liter of gas at room temperature. It is also polar covalent compound, soluble in organic non-polar solvents also, and the examples may be acetone and toluene. Now experiment to demonstrate the density. You see this one. It can be proved by pouring the gas in a jar with a burning candle as shown in this figure. Now as we know, hydrogen chloride is heavier than air. Air can be easily displaced when hydrogen chloride gas is transferred to this gas jar. Now the candle will be extinguished because HCl gas is heavier, occupies the lower portion of the jar and forces the air out of it. So these experiments proves that HCl gas is neither combustible nor the supporter of the combustion. Now here this one you can see, take 2 gas jars A and B. These 2 gas jars have been taken. These are filled with air. A is filled with air and B is filled with hydrogen fluoride gas. Invert B over A as shown. Invert B over A. So there will be the transfer of gas. Hydrogen fluoride gas will occupy the jar A and the air will be occupying the jar B because air is lighter than hydrogen fluoride. Now take out this gas now. This gas jar, take out this gas jar. That is now it is filled with hydrogen chloride. Introduce a rod dipped with ammonium hydroxide. So white fumes will be seen. So this shows that hydrogen fluoride disappears air as it is heavier than air. Now demonstrate high solubility of HCl. There is a very popular experiment called fountain experiment. There is a great solubility of the gas and this can be demonstrated by this fountain experiment. Take a dry round bottom flask filled with hydrogen chloride gas. Now arrange the apparatus the way it is shown over here. On the mouth of the flask, fix a rubber stopper with 2 holes. Through one hole, you pass a long jet tube. This is the long jet tube with a nozzle. And through this other hole, you pass a dropper with few drops of water. Put the jet tube in the beaker containing blue litmus solution. So this is the blue litmus solution. This jet tube is put over here. Now press the dropper. It will be seen that the blue litmus solution enters the jet tube with a great force. If you press the dropper, you will be seeing that blue litmus solution will be entering through this nozzle, forming a red color fountain. Now what is the result? Water goes into the flask from the dropper. HCl gas is present in the flask. It is dissolving due to the high solubility, thereby lowering the pressure inside. Outside pressure is higher, pushes the blue litmus solution inside through the jet tube. So the blue litmus solution turns red due to the acidic nature of hydrogen chloride gas. So, due to high solubility, hydrogen chloride gas fumes in moist air, forming tiny droplets of hydrochloric acid. Thank you for your patience hearing. In the next video, we will be discussing chemical properties of the hydrogen chloride gas, formation of hydrochloric acid, its applications as well as testing. Thank you so much for your patience hearing.